Welcome to my presentation. In this presentation, let us look at sum and difference of two cubes, and we will talk about the procedure, and then we will use this procedure to solve some simple example problems. Let me explain this. If A and B are real numbers, or if they are algebraic expressions, or if they are variables, it could be any of these, then we can write the sum of two cubes as follows. Sum of two cubes as a cubed plus b cubed, right? So the expansion for the sum of two cubes is as follows. We write the base terms a plus b within one set of parentheses. In the second set of parentheses, we're going to write this as a squared minus ab plus b squared. This is the expansion for the sum of two cubes, a cubed plus b cubed. When we have a sum of two cubes in this manner, we can expand it this way: a plus b times a squared minus ab plus b squared. If we have an expansion in this manner, a plus b times a squared minus ab plus b squared, we can shrink it to this form, a cubed plus b cubed, the sum of two cubes form. Similarly, if we have a and b as real numbers or algebraic expressions or variables, then the difference of two cubes, then let me write that. Difference of two cubes we can write as a cubed minus b cubed, like that. And the way we can expand this difference of two cubes is as follows. A cubed minus b cubed, we can write this as a minus b in the first set of parentheses. In the second set of parentheses, we're going to write a squared plus ab plus b squared. The formulas, the expansions for a plus b, a cubed plus b cubed, and a cubed minus b cubed look very similar, but there is the subtle differences here are in the first set of parentheses. For the sum, we take the sum of two base terms, and for the difference, we take the difference of the two base terms. And in the second set of parentheses, between the first and second term, we have a negative sign. In the difference of two cubes, the sign between the first and second term in the second set of parentheses is a positive sign. So we have now written down the formulas for the sum and difference of two cubes. We want to verify whether what we have on the right hand side does that really match with what we have on the left hand side. We will check those things out in just a few minutes. But before that, I want to mention this one here as well. When we have difference of two cubes, a cubed minus b cubed, we can expand it in this manner: a plus a minus b times a squared plus ab plus b squared. And if we have an expansion in this manner, a minus b times a squared plus ab plus b squared, we can shrink it to this form and then write it out as the difference of two cubes, which is a cubed minus b cubed. Now let us go ahead and then see if we can verify whether these formulas are true or not true. Let us take the sum first. A cubed plus b cubed, and we said the formula for this is a plus b times a squared minus ab plus b squared. Let us verify this. We will call this as the left hand side of the expression. We'll call this as the right hand side of the expression. So we'll take the right hand side of the expression and then verify that whatever we arrive at is equal to what we have on the left hand side of the equation. So on the right hand side of the expression we have a plus b times a squared minus ab plus b squared. We will use the distribution process, expand it out and see what we get. Okay, so in here we're going to take a and then distribute it to every one of the terms in the second set of parentheses. A times a squared plus a times negative ab plus a times b squared. We exhausted the first term. We'll take the second term and then do the same thing. Plus b times a squared plus b times negative ab plus b times b squared. Let us expand, let us simplify this some more. A times a squared is a cubed plus a times negative ab is negative a squared b plus a times b squared is a b squared. B times a squared is a squared b. B a squared or a squared b means the same thing. We will write it. We will write the algebraic expressions always in the ascending order, right? From a, b, c, and so on, like that. And then the next term here we have is b times negative ab is negative a b squared plus b times b squared is b cubed. Now we will look for similar terms to combine, or we will also look for terms which are equal to but opposite in sign, which we can cancel. So we have a squared b, negative a squared b and positive a squared b. So these two cancel out. We have a positive ab squared and then negative ab squared. These two cancel out. And that is, therefore, that is leaving us with a cubed plus b cubed. Therefore, the expansion for a cubed plus b cubed is a plus b times a squared minus ab plus b squared is true. Therefore, this formula we can use when we have situations of this form. So we verified the sum of two cubes. What about the difference of two cubes? Let us look at that. So if we have a cubed minus b cubed, the expansion for that we said is a minus b times a squared plus ab plus b squared, like that. So here again we will call this as the left hand side of the equation, and we'll call this one as the right hand side of the equation. And therefore we will take the right hand side of the expression and then see whether we can arrive at what we have on the left hand side of the expression. So the right hand side is giving us a minus b times a squared plus ab plus b squared, right? So now let us expand this. A times a squared, let us expand, let us do the distribution of every one of the terms. A times every one of the terms in the second set of parentheses, a times a squared plus a times ab plus a times b squared. We have exhausted the first term, and then the second term we have is minus b times a squared minus b times ab and then minus b times b squared, like that. Okay, so therefore once we have it in this form, let us simplify this some more, and when we simplify this some more, this is how we are going to write it out. A times a squared is a cubed, a times ab is a squared b, a times b squared is a b squared, like that. Then negative b times a squared is negative a squared b. I'm going to write the a term first and the b term second. Negative b times ab is negative a b squared, and then minus b times b squared is b cubed. Here again we will look for terms which are similar, then so that we can combine them, and if we have similar terms which are equal to but opposite in sign, we'll cancel them. So I have a positive a squared b and a negative a squared b, these cancel out. I have a positive a b squared and the negative a b squared, these cancel out. So therefore we are left with a cubed minus b cubed, and therefore we can come back here and then say the expansion for the difference of two cubes is a minus b times a squared plus ab plus b squared is true. And this is the way we want to not only write the formula down, but we also want to verify whether that formula is working correctly or not. So we will use this procedure to solve some simple example problems in my next presentation.